Good morning, students. I am Dr.R. Rohini, Assistant Professor of Mathematics, Cardamom Planters Association College, Bodinayakanur. Today's topic is topology. What is topology? The topology of a space is the definition of a collection of sets that include the space and the empty set. The union of any sets of the sets, the finite intersection of any of the sets. Topological space is a set with the least structure necessary to define the concept of a nearness and continuity. No, reality. What is the topology? The study of properties of a shape that do not change under deformation. Rules of the deformation: one-to-one correspondence by continuous, cannot tear, join, hook, steal or pull. A homeomorphic to B. Why is topology? What is the boundary of an object? Are the holes in the object? Is the object hollow? If the object is transformed in some way, or the changes continuous or abrupt, the object bounded or does not extend infinitely far. Why do we care? The study of connectedness, understanding how the connectivity happens, analysis, how to determine the connectivity, articulation, how to describe the connectivity, control, how to enforce the connectivity. For example, how does connectedness affect morphic clustering, comparison and simplification? Problem: max reconstruction. Determine the shape from the point sample, different coordinates, different shapes. Topological properties. To uniquely determine the type of homeomorphism, we need to know surface is open or closed, surface is orientable or not, genus boundary components. Surface. How to determine the surface? Surface is a space which is loosely like a plane. The set of zeros of a polynomial equation in three variables in R cube is a 2D surface. X squared plus y squared plus z squared equal to 1. Surface and manifolds. An n-manifold is a topological space that locally looks like the Euclidean space R power n. Topological space set properties: Euclidean space, geometric and coordinate. A sphere is a two-manifold. A circle is a one-manifold. Some examples: open as closed surface. The point X having a neighborhood homeomorphic to R squared form interior. The point Y for which neighborhood is homeomorphic to R squared is greater than or equal to 0 form as boundary. A surface exists to be a closed if its boundary is empty. Orientability: a surface is R cube is called orientable if it is possible to distinguish between its two sides, inside or outside, below or above. A orientable surface has a path which brings a traveler back to his starting mirror, reversed inverse normal. Orientation by triangulation: any surface has a triangulation. Oriented as triangle CW or CCW. Orientability: any two triangles sharing an edges having opposite direction on that edges. Genus and holes. Genus on a surface is a maximal number of non-intersecting samples. Closed curve that can be drawn on the surface without separating it. Some examples: the genus is equivalent to the number of holes or handles on the surface. Example: genus 1, point line sphere. Genus 2, torus coffee cup. Genus 2, the symbols 8 and B. Euclidean characteristic function. Polyhedral decompose of a functions. B is vertices, E edges, F faces. The psi of M equal to B minus E plus F. The M has G holes H boundary components, then 2 psi of M equal to 2 minus 2G minus H. Psi of M is a independent of a polygonations. Psi equal to 1, 2, psi equal to 0. Summary: equivalence in R cube. Any orientable closed surface is a topological equivalent to a surface and G handles attached to it. Torus equivalent to a sphere with one of the handles. Psi equal to 0, G equal to 1. Double torus is a equivalent to a sphere with two handles. Psi equal to minus 2, G is equal to 1. Thank you.